All right. All right. So this is all about maps, and you've seen this slide already. It's about pre-building these maps, printing a strategic number of these maps and distributing them strategically so that people have them available and know how to use them as well. Where am I? There we go. And then creating the map books, and I talked about this as well. Creating maps that are consistent across jurisdiction. We end up with a map library. These are all created as PDF files. And so this is all about creating those PDF files. Once it's really all about, if you've worked with, well, let me see a show of hands. How many have used data-driven pages in Arcmap? Give me a reaction. Three. Well, this is what it's a great feature in Arcmap, and it's carried forward in Arcgis Pro with the map series. It's creating a whole series of maps based on a single layout, and what you do is drive the creation of all of those maps based on a polygon data set. So you can identify a polygon data set or selected polygons in that data set, and that becomes the basis for creating all of the maps. What that means is then each of the maps, I mean, it'll automatically create a map for each of the selected polygons, and the attributes that are associated with those polygons are then available as dynamic values for each map. So it means it's really all about pre-building those polygon data sets as the foundation for creating the map series. So that's what this is all about. But at a fundamental level, all you need to do is put a UTM grid on the maps you're already making. I mean, if I've been making maps for a long time. Started working at Dakota County, it was all about the county coordinate system because I was working for the county surveyor, and county coordinate system was the best way, most accurate way for capturing coordinates for parcel corners and parcel definitions. And that's still true. That is a local projection. It gives us the best representation of actual ground locations and ground measurements. So we're not replacing that, you know. All we're doing is taking data that's stored in whatever coordinate system. It doesn't matter, county coordinates, state plane coordinates, UTM or whatever, geographic, presenting it in a universal transverse Mercator projection with UTM coordinates. That's the difference. So it doesn't matter how you're storing your data. You just don't want to make maps in county coordinates for your county surveyor. That's no problem. But you know, I challenge you to, if you're an advocate of county coordinates or a local coordinate system, how many other people know about that? And it certainly is not universal across jurisdiction. It certainly doesn't scale up for the entire country. So it's important to consider that. So you're already making maps, put a UTM grid on it. You never know which maps are going to get pulled out of a drawer in an emergency situation and used. And so this is the common denominator for how we make maps useful for emergency response. Of course, they have to have the training. You can do just-in-time training on how to use the U.S. National Grid in a pinch if you haven't been able to do that ahead of time. And you may have to do it with search and rescue operations. And certainly when you get into a major weather event or something like that, there are a lot of volunteers that are going to come out, and you can do just-in-time training. Give them an 8.5 by 11 map. Give them tell them how to set the Mgrs setting on their phone so they can see where they are, and tell them to go to a certain grid location. It's not hard to do. They don't need to know all the details. So I was actually just talking with somebody in a suburban or rural county just outside of Atlanta, and he wants to start making U.S. National Grid maps and so on. He's already making maps. He's not doing the map series based on the U.S. National Grid, but he already has a map book at a certain scale and so on. And I said, put a grid on it. That's the very first thing you can do, is make sure that the grids that you are producing are U.S. National Grid compliant. So that's the fundamental message that I want to leave with you. You're already making maps, put grids on them. We need to have some kind of a spatial reference. I mean, this is something I learned a long time ago. When we were drawing maps by hand, is you always have a spatial reference on your maps. How else are you going to measure on it? How else are you going to use them? And certainly now with virtually ubiquitous GPS, everybody thinks they know about GPS because they've got it on their phones. How do you relate that to a map? Put a grid on a map. And if you're going to put a grid on a map, put a UTM grid on it so that it's interoperable with the U.S. National Grid. All right, that's the most important thing. But then it's really about creating standardized maps. So you want to have maps that are consistent across jurisdiction, as we did in Minnesota, create maps that are consistent across the entire state. Obviously, the USGS has created the USGS US topos. Those are consistent across the entire country. Those are based on 7.5 minute by 7.5 minute quadrangles, which works well when you're starting from a national scale and working your way down to a 1 to 24,000 scale. The interesting thing at a local level is that these other maps that are based on the even increments of UTM grids or the U.S. National Grid is that it works well from down to a very large scale map at a local level. And so that's where we came up with these 1K and 10K maps. The 10K maps are 1 to 24,000 scale as well, same as the US topos. So what I tell people is when you're starting from a national level and working your way down, the US topos work great. When you're working at a localized level, the maps that are based on the US National Grid work great because it's very easy to figure out which map you need to be on. Again, I challenge you with the US topos. They're all named with historic names. Trying to figure out which US topo you need for the location that you happen to be occupying can be challenging. And so that's where this 1K, 10K maps work very well because they're named using the coordinates of the lower left corner of the map. Works very well. And the name of the map also, by definition, describes the geographic extents of the map. So if it's a 10K map, it'll be something like VK85. And so we can see just by its name that it defines a 10K square, and the lower left corner at a 10,000 meter increment is the X and Y of the two characters. Then when we get to 1K map, that's a 1,000 meter by 1,000 meter, even increments. It's two characters, X and Y, which is the lower left corner. We know because it's only 4 digits that it defines a 1,000 meter square, and so on. And so that gives us the ability to name these the files, the PDF files that are associated with these maps. You have to always come up with a unique naming system. And so what are you going to use? Well, if we're actually naming the files based on the coordinates of the lower left corner, it's guaranteed unique, first of all. We can append a descriptive name. So you might have something like VK85 underbar topo or VK85 underbar aerial or something like that. So you can add that additional name for naming these map series. But that means if somebody's searching through these PDF libraries, just using the name itself, they can figure out which maps they need very easily. But then also developing some standards for the USNG data field name. So again, it's all about these polygon data sets and the attributes that are associated with those polygons, because that's what drives the map series. So there's some time involved in getting this all set up properly, but once it's set up, it's done, and you're simply able to rerun your map series, and everything works. So what you do is set the attribution on the polygons so that becomes the dynamic text when the map series runs for populating some of the fields that we'll see here. And standardizing the maps, again, based on the 1K squares and the 10K squares. Everybody understands we're talking about 1,000 meter by 1,000 meter and 10,000 meter by 10,000 meter. on even increments of the UTM coordinate system. But it works very well when you're working between these. If you think about an 8.5 by 11 map at 1 to 6,000, that's 1 inch equals 500 feet. Once you have your layout set up, you change your scale from 1 to 6,000 to 1 to 60,000, and now you use the 10,000 meter squares, or 1 to 600,000, and now you're using the 100,000 meter squares. And so what that gives you, then smaller scale maps become the index map for the larger scale maps. And you just work your way down. And it's very easy to do. Same thing with 22 by 24 or whatever format you choose. When you're working directly with, when the map extents and scale relate directly to these even increments of the U.S. national grid, it's worked very nicely to scale by a factor of 10 and create an index map for the larger scale maps. Works very well. Here you can see that. So we've got a 1K map, that's 1 to 6,000, 1 inch equals 500 feet. Multiply the scale by 10, add a 0, and now you've got a 10K map with its 8.5 by 11. Multiply that times 10, add a 0, and now you've got a 100K map, and you can label all of the squares, and so you instantly have an index map from one to the next, and it just works very nicely. So you can think about that as well. Any questions about that? Okay. Am I doing it? Oh, okay. So here's an example. So here's the 10K map, 22 by 24 inches, 1 to 24,000 scale, 1 inch equals 2,000 feet. Right up in this area is a refinery in Dakota County. Well, you know, that's a very detailed industrial area. And if we want a detailed map, again, at the same size, 22 by 24 inches, I change the scale from 1 to 24,000 to 1 to 2,400. And now I have a 1 inch equals 200 foot map showing a 100 meter grid over that same area. And so I can very easily use the 1,000 meter polygons to drive a 100 meter data set, and so on. And so the question about the 1 meter data, you really don't need it. And it would be monstrous. It's just totally impractical, and it would just be huge. And you just don't need it, because the only real grid data that you need are the polygons to drive your map series. Everything else is just lines on a map. Or if people are using the U.S. National Grid for asset naming, it works very nicely for that, because you're guaranteed a unique identifier for a light pole, a fire hydrant, things like that. But you don't need the data to actually do that. You can just, there's a tool in ArcGIS that will allow you to calculate a field value using U.S. National Grid or Mgrs. So you don't need the data all the way down to 1 meter. You're using the gridding capabilities within the map systems to be able to generate the grids on the maps or in an application. So does that help with that 1 meter question? Give me a thumbs up or unmute. And we'll see more examples. I'll touch on that along the way. Art, you okay with that? All right, great. All right, so just point out resources, because I want you to be able to go away from this and go dig. Take a look at some of these examples. If you do a Google search on USNG Minnesota maps, I think probably you'll get to this page. And if you scroll down, we actually have instructions in a zip file for getting everything that you need to be able to recreate those maps in Arcmap. And it also exists on usngcenter.org. Go down under library mapping support. Here you can download instructions for creating 1K maps and an MXD with that layout. Don't start from scratch, please. One of the other benefits of this, if we all do things the same way, we get to leverage each other's efforts and make improvements together as in learning and learn from each other. So there's no reason for anybody to start from scratch with creating these kinds of things. And if you got a better idea, I'd be glad to hear about it. I know some people are creating some maps for 11 by 17 and things like that. The scale can be challenging, and I've found the 8.5 by 11 and 22 by 24 formats to work pretty well. They're pretty economical to print. 8.5 by 11, obviously anybody can print those. But there are certainly other options. But let's try to create some standardization on this stuff and really take the stuff that's already out there and start with that at least. So you can download the instructions. It takes you through actually setting up the map book. And then you have to download the Usng grid data. And this again gets to that question about the 1 meter data that you really don't need, but you do need polygons for whatever increment of the U.S. National Grid that you want to use for your map series, just as you would for whatever kind of map series you want to create. If you're creating half section maps or section maps or something like that based on the public land survey, well, you got to have polygons for the half sections and set up all the attributes accordingly. Same thing for creating these U.S. National Grid maps. Now, all of that data exists down to the 1,000 meter squares nationally. So you can go and get all of that. And there is attribution on there already for the U.S. National Grid. I've really found that expanding on that works nicely. There are some improvements that can be made in the data that is out there. It's actually organized into UTM zones by state. And so for the state of Minnesota, we actually have 3 different UTM zones. State of Wisconsin has 2 UTM zones. So you have to download the 2 pieces. What I've found is that it works real nicely just to mash that stuff together in WGS 84, keep all the attribution there. And then you're working with 1 polygon data set. So you'll do some things as you get more familiar with it and you start playing around with the data. You'll find some ways to be able to streamline that and come up with really a good foundation for creating your map series, whether it's for the entire state or for a county. Just play around with that and you'll find some efficiencies. But it's all about building those data sets. You can actually then download the MXD. This is for the 1K maps, 1 to 8.5 by 11, 1 to 500 feet. And then you follow the instructions for making the maps and map books. And I believe these instructions are really pretty straightforward. You can just follow the instructions. You don't have to do anything to the data. It will just work. But then what you'll find is that if your county is split by that grid zone boundary, there's some other stuff that you're going to have to do, as I will show you here. And then step through creating the USNG map book. So it takes you through the preparation and setting up the data-driven pages in Arcmap. And I think this is really pretty straightforward. Just follow the instructions. And if nothing else, it's a good way to learn. If you haven't played with data-driven pages, just work your way through this. Use the standard Esri base maps and make some maps. It'll help you understand a little more about how it all works, and then you can build on top of that. So it's all about building the data. So I've got the 1K polygons for the entire county, but what I can do is then use something like a municipal boundary. This is the Apple Valley showing on the screen. I can select all of the polygons associated with Apple Valley. And then I can make the index map. I can use these selected polygons for data-driven pages and just recreate all the maps for Apple Valley. So I can do it county-wide, or I can just do it for a selected area. Obviously, you could get more sophisticated, if you have a way of tracking updates to your database. You would be able to figure out which are the polygons that are affected by the changes in your database and only create the maps that have actually changed since the last time you updated your database. I mean, it's pretty slick. Lots of different ways that you can leverage this. Okay, so then setting up data-driven pages, just some screen grabs of that. You specify the layer, and then you can specify the sort field, and then there are options on the name of the of the page, and so you can actually use the attributes. So if we have an attribute on the polygon that is the U.S. National Grid designation, like 15T VK8475 would be a 1,000 meter square. That's an attribute value that's unique on each of the polygons, and we use that for the file name. And so as it creates all of these maps, they all get named uniquely, given the correct name, and it works pretty slick. We do want to center and maintain the current scale. We don't want any best fits and things like that. The 8.5 by 11 format at 1 to 6,000 scale works really nicely for a 1K square with a little bit of overlap around the outside. So it still gives you, the overlap between the pages and things like that, which is nice to have. We've actually now we've changed our format a little bit to make the map display, the map frame square, and allow some extra room down at the bottom, so that we're all set up for doing situational overlays. So we got extra space, white space down in the legend area for, tornado damage or whatever. So think about that as well. And then you want to be able to set up a location indicator, and so that's going to be another map frame. You can do this very easily with the same 1K polygons. You have another field in there that is just the numeric portion. Again, at a localized level, we don't need to keep beating to death the 15T-VK. There are only, in Dakota County, we have two 100,000 meter squares, VK and WK. And in fact, Dakota County is about a medium-sized county, I think. The numeric portion of the U.S. National Grid does not duplicate from one end of the county to the other. Now, because there's that 100,000 meter boundary right in the middle of the county, the numbers actually increase up to 999 at that point and then start over at 0. So that's can be a little bit weird, but so we do put the VK and WK on the maps so that people don't get confused about that. And they just know VK's on the west side and WK's on the east side. And it's not hard to figure out, but everything gets numbered sequentially. Even if you don't have all the pages, it's still going to be sequential. So all the pages, when you can order them very easily for creating the map book. You don't have to be numbered 1, 2, 3, 4, 5 in numerical order without any gaps. It's okay if there are gaps in there because it's still sequential. So you have the index map. It shows you all the page numbers, actually numbering from the lower left corner up and so on. But it's a very logical system. It's very easy to be able to see what are the adjacent numbers and things like that. And so some of the things on the bottom of the map, I'm not sure how well it's showing up on your screen, but we have the grid zone designation box, which has 100,000 meter square. We have the grid zone itself, which also shows up in this text. And you'll see this in greater detail. It's pretty small here right now. But things like the map number and then the index to the adjoining pages is all coming off of those polygons. So you don't have to go to every map and put this in. It all gets generated automatically using data-driven pages in this case. These are attributes of the page for each page as it's created, which is pretty slick. And then the pages themselves. So you give it a file name, which is actually the root of the file name, and then it appends the whatever you're using, whatever field value you're using for the name, and we use the USNG. And you should use the full USNG specification. So here we want to use the 15T-VK along with the numbers. That way, if for some reason we merge it in a much larger library, the names will still be unique and they will still describe the actual location of that map. So use the full designation. Don't cheat on that at that time. Some of the other things you need to think about, the projection should be UTM NAD83. You need to put a grid, and it should be a UTM grid of an appropriate appropriate increment. The grid zone designation box, we'll go look at these in detail. The grid labels for small scale and large scale, the graticule, and the magnetic declination diagram. So if we look at a map, let me see where I'm at here. Oh, okay. In Arcmap, you can just go, oops, thought I was live there. You can just go into add a grid, and you can specify U.S. National Grid. It's right in there. You don't have to do anything. Now, problem is the way this is set up is it really only works down to a 1 to 24,000 scale. You know, it's really designed for the way the USGS creates the maps at a relatively small scale. At the local level, we need to do some additional work to be able to make the gridding work properly. So it's important to know what it is that you're trying to achieve here. You know, you can't just push the buttons and expect that it's going to do it properly. You need to know what to do. And we do add a graticule as well. You know, we did show in the National Search and Rescue Committee standards, we need to be able to support both the U.S. National Grid and degrees, minutes, seconds. Degrees, minutes, decimal minutes. And so it's important to have both of those on the maps. And so here you can see that. I should have showed a different example because we've actually changed this one. But here you can see we've got this. We have the full coordinates in the corners, and you should always have on the at least one instance on the map where you're showing the full coordinates in X and Y. So you want to make sure that typically it's in a corner. And then we're labeling the grids, and this is really the first iteration that we came up with. So we can see that the name of this page is actually 7250. And by just using the digits on the grids, we can get to a grid reference for a 100 meter square. So 721501 would be this square up here. Very easy to do. We had some debates really with people are doing this across the country, and what we've actually come up with as an extension of the standard is to use 3 digits for the grids themselves, and that I think fits the standard better. But here you can see standard text that needs to appear on your map. 100 meter grid, it defines the increment of the grid, U.S. National Grid, North American datum 1983, that's part of the standard. Grid zone designation 15T, 100,000 meter square identification VK. The VK and the 15T are all being driven from those polygon attribute values. And then in the same way, this grid zone designation box, this is a standard too. So then we do in Arcmap, we can really just do the U.S. National Grid, but then we need to add these 100 meter lines when we're doing a 1 to 6,000 scale map. If you're just doing 1 to 24,000 scale, U.S. National Grid works fine. Once we get to a larger scale, we need to start adding something else like 100 meter grids. And then we need to set the interval. There's some weird to set the interval to 100 meters. There's some weird things in Arcmap. I don't know if they fixed this by now, but I had to actually set the origin and do a slight offset to make it work. So again, it's all about knowing what you need to do and then use the tool to accomplish that, as opposed to letting the tool drive it. You need to know what you need to know first. Putting in some corner labels. It's setting the principal digits. And so again, the little numbers and the big numbers, the numbers and the superscripts. And so that's the convention that helps people interpret the UTM coordinates into U.S. National Grid references. The Bible is the FGDC standard. You need to read this. There's a lot of good background information. You can see it's dated 2001. I don't think it's changed since then. But this is where it all starts. This is what describes the elements of a U.S. National Grid compliant map. So you need to look through this, and I'll just point out a few things. It shows you the grid zone designation box. It shows you that text. You need to define the increment of your grid on the map, grid zone designation in 100,000 meters squared. Shows you how to label the grids. Again, having at least one complete UTM coordinate on the grids on your map. And then this is another part of the standard. If you are at if your map includes the intersection of 10 kilometer squares, they are labeled in the corners like this, as well as in the marginalia. And that all happens if you just click U.S. National Grid and you're working at 1/24,000 scale. That this just happens, and it'll show up on your larger scale maps as well. You can see how the grid zone designation box changes, and so that gets a little more challenging, and I'll show some more detail about this in the Arcgis Pro examples. And so here's just all of the examples of the grid zone designation boxes, depending on the different configurations. Now, here's one reason why creating maps based on the U.S. National Grid, even multiples of 10 on the grid lines, works well, because you don't encounter this very often. So that works very well. But be aware, and you can drive a lot of this from the automated data-driven pages too, and I'll show that. Again, graticules. So these are your geographic references. And so we do need to put degrees, minutes, decimal minutes. The typical technique is to put ticks so they can be differentiated from the grids, so you don't have grid lines all over the place. We typically put the graticules in as across a plus sign at the intersections, and that can all be done through the gridding as well. And do that at some kind of decimal degree increment. So you need to play around with that. You need to make sure they're labeled in degrees, minutes, decimal minutes, and you just got to find a convenient increment for the scale that you're using. 0.1, 0.25, whatever. You might play around with it. 0.2, play around with that. But you want it to be a nice even increment. Don't let it just, if you don't pay attention, you'll end up with some weird thing like 0.2763 or something, and that's just confusing. Find a nice even increment. 0.125 is a certain even number of seconds and things like that. So play around with that. Magnetic declination diagram. This is true north, magnetic north, and grid north. This used to be a big problem. Esri had a tool for creating this automatically, but it was only included if you paid for the military extension, which was really unfortunate. However, Shared Geo, once again, thank you, came up with this little utility, which is very useful. It'll automatically create the declination diagram based on certain arguments, and this is a web service, so it's actually just been updated. Actually, I'll show that in a second, but it has the arguments that you see there. In case you didn't realize, magnetic north changes over time. It's actually moving, so you do need to specify a year. Specify the latitude, longitude of the center of your map, the UTM zone, and then a size for the image, and it simply returns this as a PNG. Well, that means you can drive this from your data-driven pages as well. You include in your polygon the latitude, longitude of the center of the map, which you can calculate very easily, just using the standard Arcmap tools, calculate geometry, and then put in the other attributes. So you can actually create this full URL as an attribute on the polygon that's being used to create your map. And as it creates each of those maps, it will go out, hit this service, return the PNG, the correct magnetic declination diagram for that map, and plug it into the map. Very slick. You can actually go to mdd.sharedgeo.org, and they just recently added actually a forum, so you can just go play with it. And you could go type in all the arguments on the URL address if you wanted to, but you can also just go to mddsharedgeo.org and use the little form that's down at the bottom, and it'll generate the PNG. So pretty slick. So if you just need to create one for a single map, there's a nice way to do it too. So then you get to, I'm not sure why I put this slide in. Once again, you've seen this. We're creating the map books. I think we're actually going to look at them. Okay, here's the new example. So this is the next generation of these 1 to 6,000 scale, 8.5 by 11, 1 inch equals 500 foot. So we're including the magnetic declination diagram, which we didn't before because it would have been painful. You can see we've got all the same stuff that we've had that you've seen on the 1 to 24,000 scale maps, but then look at how we're labeling the grids. So now the principal digits are those that apply at this scale. So again, the full coordinates, and then using the 3 digits as the principal digits, which gives us the actual grid reference. So 833511 is the grid reference for this 100 meter square. So I think that it makes it much cleaner. It really follows the convention much better, and encourage you to do things that way. So then we've got a special case, grid zone boundaries. This was actually, some people thought that we can't do U.S. National Grid because we have grid zone boundaries. Well, it's just a special, cartographic challenge. It's not a deal breaker. And I've dealt with this in a specialized way. Because what you actually have when you download the 1K polygons, for example, you actually get partial polygons at the grid zone boundary, because it's like a zipper. You'll see it here in a second. And so to make all of them, so if we use those little polygons, they would be centered on the map, which might be good, but I think it's a little confusing because the map looks different than any other map. So instead, what we do is just artificially extend that particular polygon to make it a square, and using all the attribution to create a map that covers the area that square would occupy if it were extended. We cannot. Every location has one and only one U.S. National Grid reference. You can't just arbitrarily extend the coordinate system out into another zone. All the GPS applications will automatically make the switch as you cross that boundary. So we don't want to create confusion by artificially extending that. So what we really need to do is represent both grid systems, the grid system from both zones on the map. And then we have to have some additional fields for the grid zone designation box. And bottom line, Arcmap gridding fails. So those of you that aren't into Arcgis Pro yet, you really have to deal with this problem. You're going to want to go to Arcgis Pro, and really everybody should go to Arcgis Pro. It's only a matter of time. There's no reason. This is a good reason to do it now. It actually handles this problem very well. We had to really go through some contortions to make Arcmap work with the first set of maps we made for Minnesota. Now in Arcgis Pro, it does it right, and it looks really nice. So here's the grid zone boundary. You can see it in the heavier line running down kind of the right third, and you can see how the grid lines go off at an angle. It's skewed, and so you have these partial polygons that run all the way down. Well, that's correct. That's the way it's supposed to work, and you can measure and get a correct location any place on this map. Now, it takes a little bit extra to train responders and people that are using the map to measure correctly, but it's really not hard because you measure all the way up to that point, and you need to know which grid zone you're in. And when you're measuring to an adjacent point, you have to measure from the other grid, and you're simply subtracting. So you're just measuring in the opposite direction. It's really not a big deal. It's just it'll match the GPS coordinates that you're getting, which is very nice. If we just look at how that looks, if we look at two maps So what we end up with by creating those artificial polygons, or pseudo polygons, as I've called them, what you end up with is all the maps along that grid zone junction in one UTM zone, and then the overlapping maps in the adjacent UTM zone. So they all overlap, and so you're basically working from, if you're working in one UTM zone using the map naming convention, you get to the right map. If you're in the other UTM zone using the map naming convention, you still get to the right map, and then you can see that you have to go over to the next UTM zone. So it's very easy to work with. But you can see how this looks with the grid skewed. If I just align, what I'm doing is I just rotated to align that grid zone boundary, and if we just clip it at that point, that's how it works. And so you can see that the aerial photography underneath still represents the detail the same. And all we're doing is overlaying this grid on top of it for measuring purposes, and it all works. So it is a special case that you have to deal with at the grid zone junctions, but really in ArcGIS Pro, it isn't a problem. Oh, okay. So now I'm going to go to ArcGIS Pro. Let me see. Yep. All right. So give me a second here, because what I'm going to actually do is bring up ArcGIS Pro. I thought I would have. Oh, nice. I'm going to stop sharing for a second. Make sure I got my password right. And I'm going to bring up ArcGIS Pro. And what I'm going to do is actually share my window, because it makes it'll make my ArcGIS Pro a little bit bigger on your screen, I've noticed. So give me a moment. Oh, that's not what I wanted. And so this is for the 10K maps, but the same concepts apply at a different scale. But again, this is available. If you're going to make 10K maps in Wisconsin or anywhere, you should start with this. There's no reason to start from scratch. And let's see.
Randy, we can't see your screen if you're.
Yep, I am just getting set up. Thank you for that.
Okay.
I need to do a share on a window now. Here I am. There we go. Now you can see?
Yes.
Okay.
It's coming in.
Yep. Okay. All right. So I'm opening up an ArcGIS Pro project now. Let's see. I've got a script I'm going to follow here. So this is working live, but I think it's the best way that I could show you what I wanted to show you and react. All right. So now everybody can see that. All right. Okay, so this is the ArcGIS Pro environment, and it's a project file now in Esri terms. So we're kind of going back for those of you that do ArcView. We're back to projects instead of map documents. So the nice thing is, first of all, where a map document was document centric, you had to create multiple MXDs for different variations of the same map. Now you're working in a project, and so you really have the concept of view of maps and layouts, which works very nicely. So this is the project for creating the 10K maps for the state of Minnesota, 1 to 24,000 scale, 22 by 24 inches. And the same concepts apply at other scales too. But we have 3 maps, and let me see, I've made this really small, so let me see. So we have 3 maps. We have 1 map for each UTM zone. In Wisconsin, you have 2 UTM zones, so you would have 2. And the reason is because we have to set the UTM zone so we get the right projection. And then we have a corresponding layout, map layout for each of those zones. So we've got I've called them 10K14, 10K15, 10K16. And then there's one more for each of those zones to deal with the grid zone boundary. So essentially you have a map for each UTM zone, and you've got 2 layouts for each UTM zone. All right, so what I want to do is show some of the details about so in Arcgis Pro, it's called a map series. In Arcmap, it was called data-driven pages. So I'm just going to go through a little more in how you create these maps. And in this case, it's a map series in Arcgis Pro. So here you can see 1K squares for the entire state of Minnesota. The grid zone junctions are apparent, and we'll see that in a little more detail here. I've got this thing called the Usng Reference, which shows the UTM, the grid zone, and the 100K squares. And so you can see all of those labeled, just so you can see how this all works. And so each of those smaller squares are, I'm trying to follow my script here. I think what I wanted to do was click on one. And so now you can see I've selected one 10K square, 100K square, and the grid zone designation. And we can just look at the attributes. Let's start with the grid zone. So there you can see the whole grid zone. It has one attribute, NG-GZD, which is 15T. And obviously for the other ones, it'll be different, 15U, 14T, and so on. If we look at the 100-kilometer square, again, we can see NG-GZD. And now you see the 100K2 and NG. And I've adopted NG as the convention for naming the attribute for the full USNG designation at this resolution. So you'll see that when we get down to the 10K square as well. So we got the National Grid stuff broken out into pieces, and that's so we can label the grid zone designation box and the other text. And then NG is for the full designation. And you can see how you derive these values from the National Grid, the full National Grid reference. You just pick out the characters. It's a calc operation on the field. And if we look at the 10K square, this is what actually drives the map. And so here you can see more. You see the full NG, 15T, VM53. So that's the full designation for that 10K square. And then breaking out the pieces. So we got the VM is 100K square, 10K2, that identifies a 2-character representation of the 10K square. So I just want the 5.3 in some cases, and so on. And here's 10K4, and so now I know that that's the full VM53, and so on. And then you can see the URL for the magnetic declination diagram, and that has the full, all of the arguments for driving. Well, before that, you can see the lat long. So I calculated the center of the polygon in geographic coordinates. So we have the lat long of the center. And then from there, this is another calc to build that URL. All right. And then I've also added, for consistency, a F-name field, so I could use that directly. But anyway, you can see the attribution there. Any questions about that? I mean, you're familiar with Pro, but you can see how you set up the attributes on the polygon to drive all of this. And I am running low on time, so I'm going to move along. Let's see, the attributes. All right, so if we look at a layout now, we can look at some of these pieces here. So I'm just going to zoom in. So here you can see that text. You've already seen this a couple of times. So the 15T and VK gets driven by the attributes. Grid zone designation box, again, the VK and the 15T, those are dynamic. Actually, if I click on here, let me just hover over this for a second. I hover over this, you can see the text. And if you look down, you can see the text that is static, and then you can see the DIN in the greater than, less than signs. DIN type equals page, property equals NGGZD. And so that's what's pulling that value out and plugging it in for each map. And that's just the convention. And you can go, it's just using these dynamic text tags in your layout. But it just changes with each page. All right, we looked at the grid zone designation box here, data sources. Another dynamic text in here. If you look down at the bottom, base map, again, dynamic text, layout name, and the property is service layer credits. That's a piece of dynamic text as well. So it's not related to U.S. National Grid. That's just another piece of dynamic text that you can plug in. It's kind of nice to be able to take the credits out of your map frame, which can be rather annoying, especially on a large scale map or a smaller map, and put it into the marginalia. So that's kind of a nice thing. We've got the standard legends. These are all the overlays. Actually, all of these layers are coming from national repositories, and it really helps drive the need to update those data sets. And so we're working to standardize that in Minnesota as well. Some additional layers that we've added in Minnesota: standard disclaimer, map name. Map name is dynamic text. You can see that again, NG10K4, and the location map frame, and so on. Scales. It's important. Your bar scales are important because you never know with a PDF file. Somebody may take my 22 by 24 inch map and print it 8.5 by 11. Well, the scale is no longer 1 inch equals 2,000 feet. So that's why you want to make sure that you reference the intended size of the map and then all the scales. The north arrow is the magnetic declination diagram. There you can see I'm using the value of the field URL 15 and so on. Okay. Then also, if we go into the map frame, grids, and this is what's really nice. I'm going to just feed this along and go right to the. Well, let's see. I'll just show this first. So, if we look at the grid. It's the, you know what, that's not, there it is. The grids, the most important thing with the grids is that it has this checkbox right here, clip to UTM zone boundary. So you add a grid for UTM zone 15, you add a grid for UTM zone 14, and you say clip them at the UTM zone boundary. And it does all the labeling, it does everything as it should. One thing, it gets a little more complicated, is the labeling of the grids. You can see everything is here. There are some defaults, but again, it's getting familiar with the dynamic text. Esri has some pretty good help on this. I encourage you to go there. It's linked, tells you how to do grid labels, and it actually has labels for U.S. National Grid in here somewhere. Here we go. Measure MGRS label examples. So we're going to have to expand here again. All right. So it looks a bit more. It is more complex for labeling the grids, but very flexible. And again, you just need to get familiar with it all. So with my 3 minutes left here, what I want to do is go to look at what I did is create this map X just for viewing. And this is where I really set up the different map indexes. So we have the 10K squares, and we looked at those. And if I zoom in and look at one of these, here's where you can see it's actually a partial. Let me see, I gotta wait for my, it's actually a partial polygon. has all the attribution. But so what I did is, let's see. Where am I here? Oh, I closed MapX. I'll do that. All right, I'm gonna have to. All right, I lost that. Pardon me. I got to recover here real quick. All right, sorry about that. All right, so where did that go? Sorry about this. Perils of, come on. All right, so real quickly, so we've got those 10K squares, but then I've created these pseudo polygons, and here you can see what those look like. And so those are actually full squares along the grid zone boundary, along the grid zone junction. So had to create those 1K squares, and there are different techniques for doing that, and then copy the attributes from the partial polygons and then complete the additional polygons. So what you end up with as the end result here is creating these different, these are definition queries for the different data sets. So if we look at the standard case, these are the polygons used for creating the UTM Zone 15 standard maps. These are the ones for Grid Zone 14, and these are the ones for Grid Zone 16. Okay, but then we've got the special cases. 14x, 15x, and then we've got a little bit in 16. And so if we just take a peek at one of those, and we'll look at worst case, which is up here. There are a bunch of additional attributes. And so here you can see we got the same standardized attributes, but then we had to add the grid zone east, grid zone west, 100K east, 100K west, and so on. Grid zone north, grid zone south, and so on. So those are all consistent. These are just definition queries on that, because you could select all the ones where the east and west are the same and the north and south is different, and then that tells you that it's one of the horizontal seams, and then you could look for the other ones where east and west are different, north and south are the same, and so on. So it all works. It's all really slick. It looks complicated right now, but it really is slick once you get familiar with it, and then being able to drive that. And if we just look real quick, and we're running out of time, but I'm just going to go to the layout for one of these grid zones and one of the grid zone junctions. And if I zoom in here, where am I? Here you can see the grid zone junction labeled properly. The grids all come in properly. This is the map for UTM Zone 15. So the Zone 15 grid is orthogonal because this map is named for UTM Zone 15. It's presented in the UTM Zone 15 projection. And then the adjacent zone grid looks like this. And then we've got one for 14 as well. And if we just go in and look at the grid zone designation box, and I'm just going to go real quick and show you. If I go to the grid zone designation box, the different pieces here, this is it. Yeah. So if I just hover over this, what you can see is it's using the value GZ, DGZ. And if I look at the attributes on this, and I actually have to select it. And display the attributes. Is that it? Oh, here. There we go. What you can see is that all of that is done using the text tags. And so there you can see it's a combination of underline, a vertical bar, changing the font size to make a subscript, and so on. So the important thing is that all of that could be done by calculating values from the U.S. National Grid grid reference designation and the appropriate text tags, so that it'll automatically populate that grid zone designation field without having to go in and make a map for every possible different combination of grids of the grid zone designation. So, you know, that was a problem before. You actually had to. There was the one piece that wasn't dynamic, was the grid zone designation box. But this was a technique I learned from somebody else that participated in this, and it's really pretty slick. So with that, I'm out of time. Apologize for running over a little bit. I know there was a lot real fast. The most important message is don't start from scratch. Most important message is put grids on the maps that you're already making and make it a UTM grid. And make sure you put in the grid zone designation box. Read that FGDC standard. It'll tell you how to do that. Go download the examples that are out there. I had mentioned that NAPSIG has an Arcgis Pro project with tasks that'll step you through downloading the data and creating the maps in Arcgis Pro. I had all the examples and instructions for Arcmap in the MXD. You can download that and play with that. That'll take you through the steps as well. I intend to do that with this Arcmap Arcgis Pro project. I just haven't done it yet, but if you want it, email me. I'd be happy to package it up and send it to you, and you can start with that as well. And if you have any questions, I'd be happy to hang around afterwards, or feel free to contact me at any time, and we can have a chat.